Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about singly reinforced beam vs doubly reinforced beam. Singly reinforced beam. What is singly reinforced beam? A singly beam is the beam which is provided with longitudinal reinforcement in the tension zone. Compressive forces are handled by the concrete section in the beam. The beam that is longitudinally reinforced only in tension zone, it is known as a singly reinforced beam. In such beams, the ultimate bending moment and the tension due to bending are carried by the reinforcement, while the compression is carried by the concrete. But it is not possible to provide reinforcement only in the tension zone, because we need to tie the stirrups. Therefore, two rebars are used in the compression zone to tie the stirrups, and the rebars act as false members only to hold the stirrups. Reinforcements are provided to oppose tensile stresses due to shear and bending in beams for singly reinforced beam sections. Practically, for singly reinforced beams, two additional bars are supplied in the compression face of the beam so that stirrups can be tied with bars easily. These extra reinforcements are of the nominal diameter of 8 mm or 10 mm. We take it practically, it is not possible to make available reinforcement only in the tension zone, due to we need to tie the stirrups with it. Therefore, at that place, two rebars are utilized in the compression zone to fasten the stirrups, and the rebars work as false members just for the stirrups holder. The loads handled by a beam are transferred to walls, columns, or girders, which then transfer the force to adjoining structural compression members. Procedure of singly reinforced beam design. Calculate the value of NB by the given formula, where N equals critical neutral axis constant. Using this below method for find the value of J, where J is known as lever arm constant. For determine the moment of resistance coefficient. Select appropriate breadth, B, and compare the bending moment and moment of resistance with the sufficient depth of that section. Calculate the value of Et by the given formula where Et equals area of tensile steel. T equals allowable tensile stress in steel. For a particular beam section, it is necessary to give reinforcement, steel bars, in the compression and tension zone. If the reinforcement is only in tension zone, then it is called singly reinforcement beam. In both cases, there will be load in tension and compression zone. This is because it is not possible to figure a beam structure without stirrups. To hold the stirrups in its standing position, it is necessary to place two reinforcement in the compression zone of singly reinforced beam. However, those two will never carry or pass loads in its body, and it is just fake. In a beam, the topmost section is called the compression zone, and the bottom part is called the tension zone. Doubly reinforced beam. What is doubly reinforced beam? The beams reinforced with steel in compression and tension zones are known as doubly reinforced beams. This kind of beam will be found essential when headroom consideration or architectural concern the depth of the beam is restricted. The beam with its restricted depth, if reinforced provided on the tension side only, it may not have sufficient moment of resistance to resist the bending moment. By raising the quantity of steel in the tension zone, the moment of resistance cannot be increased indefinitely. Generally, the moment of resistance can be increased by not more than 25%. Beyond the balance moment of resistance by making the beam reinforced on the tension face. These bars shall withstand in compressive stresses and are provided with reinforcement in compression face. Beams, when subjected to torsion, are provided additional longitudinal and shear reinforcement to resist bending, and shear stresses developed due to torsion. This doubly beam is also used in the following given situations. The outsider live loads may alternate, i.e. it may occur on both faces of the member. For example, a pile may be pulled up in that manner. The tension and compression zones may alternate in all cases. The loading types may be eccentric, and the eccentricity of the load may be changeable from one side of the axis to the other side of the axis. The member may be intended to shock or impact or accidental lateral thrust. Procedure for the doubly reinforced beam is given below. Step 1. Calculate the moment of resistance, limiting, for the given cross-section, mu lim, using the formula for singly reinforced beam. Mu lim equals 0.87.f y .ast 1 .d1 0.42 su max, or for balanced section in a beam. AST 1 equals 0.36 su. Maximum F CKB / 0.87 F Y. Step 2. Factored moment mu lim, then a doubly reinforced beam is necessary to be designed for an extra moment. Mu lim equals F SC.A SC DD F. SC value from is code page number 70. Step 3. Additional area of tension steel AST 2. AST 2 equals A SC.F SC 0.87 F Y. Step 4. Total tension steel AST equals AST 1 plus AST 2. Difference between single and doubly reinforced beam. For a beam, it is necessary to provide reinforcement, steel bars, in the compression and tension zone. In a beam, if the reinforcement is only in the stress zone, it will be called the singly reinforcement beam, and if the reinforcement is in the tension and compression zone, it will be called the doubly reinforced beam. In both cases, there will be a rod in the tension and compression zone. This is because it is not possible to form a beam structure without stirrups. To keep the stirrups in a standing position, it is necessary to place two reinforcements in the compression zone of the reinforced beam singly. However, these two never carry loads on your body, and it is only fictional. In a beam, the upper section is called the compression zone, and the lower section is called the tension zone. Why we provide doubly reinforced beams? This type of beam is provided mainly when the depth of the beam is restricted. If a beam with limited depth is reinforced only on the tension side, it may not be strong enough to withstand the bending moment. In order to increase the load capacity of the section moment, the limb is subjected to a shock or impact or accidental lateral impulse. A doubly reinforced beam is provided to increase the strength of a beam with limited dimensions. Minimal compression reinforcement is provided to keep the shear reinforcement. Stirrups, in position and increase the ductility of the beam. For safety reasons, we always provide a doubly reinforced beam to combat wind forces, seismic forces, and temperature stresses. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.